there, we are Team RM and MHP and welcome to our demonstration video. My name is Horsnell-Proud and together with my teammate Ryanosuke Matsunaga, we combined AI enemy searching and chasing behaviors with procedurally generated animations placed over a very creepy spider mesh to create the basis of our project. Together they form a stealth and speedrunning environmental transversal and avoidance game. Heavily inspired by the stealth mechanics in older Metal Gear Solid games, the aim of the game would be to reach various objectives or the end of the level without taking too much damage from alerting various enemies throughout the level. The player character has health represented through a health bar UI that updates when damage is dealt from collisions with the enemy characters. Scores could then be calculated by the time taken to complete the level and the amount of health left at objective complete. We are very happy with the development of our game concept, and while preferably we would have developed an example level to showcase the environmental transversal and capabilities of our AI enemy system together with the scoring system, we feel that our project is a good demonstration of the ideas and systems that we developed throughout the assessment. I will now talk through my contributions before passing to Ryanosuke. So here we see the main logic for our enemy character, which is currently as our spider in our level as we see here. So we have our header file, which sets up all our variables and functions that we need. And in our CPP file, we see here that we have our setup of our main collision detection spheres and our light source, which will change depending on whether the character is chasing or searching for the player. We also have the setup of our on-component begin overlap and on-component end overlap functions, which allow us to set certain variables here that will be used later on for our line trace, for our line of sight mechanic. We also drop a few debug spheres at our last seen location, just as a visual clue when programming to see where the enemy character will be heading. In our notify hit implementation, we have our damage system. So at the moment it is set to 0.5 per hit, and we also spawn our player hit particles, so that's our blood splatter effect on our hit. Our AI move completed is actually how we use to pass and tell if we finished a move and whether we should start searching again or not. And our search implementation uses a wide variety of checks and conditions to see if we should actually be rotating, and to make sure we're not rotating and moving at the same time. This is then used to pass to our AI control system, which has a function for our random patrol. This is quite useful as it adds a bit of life to the character, as it will choose a random spot within a reachable radius in our nav area and send our spider character there, which can then be used by our on AI move completed to pass back to the rotate search if we haven't found the plan. And down here we have our line of sight trace mechanic, which actually is used to send the character to the player location. So this is our line of sight, but it is also how we tell the character to chase. So we draw a debug line trace from the character to the last seen location. And we have a generate random color, which is just used for the debug lines and the spheres that we drop throughout the level. We have our replicated variables, which is how we are achieving multiplayer, and our spawn hit particle system.
I'm Ryunosuke Matsunaga. Student number is 14350-538. In assignment 3, I undertook the procedural animation subsystem, which involved generating animation system through the code and manipulating the mesh skeleton based on the geometry. I chose the procedural animation for assignment 3 because the Unreal Engine offers a vast amount of cinematic and animation system, and I wanted to touch some of them. I used a technique called inverse kinematics, which plays a big role in procedural animation, particularly for moving legs without requiring individual adjustment for each part. Originally developed in robotic industry such as car assembly, in the game I use raycasting to position the legs edge and prevent the collision with other objects. Bringing together enemy AI and procedural animation was surprisingly straightforward. I simply added spider mesh into the enemy AI mesh sections and included control rig for the animation sections. I should have used C++ more for procedural animation in assignment 3. However, using Blueprint certainly helped avoiding extensive refactoring or merging two works. For the polishing part, I focused on creating blood VFX, which is triggered by collider interaction between player and enemy. I obtained the texture from online and employed the dynamic parameter. Dynamic parameters utilizing 3 dynamic scalar value to modify the texture color channels, specifically the red, blue, and green. This approach enabled the creation of dynamic texture within the Niagara system and deforming the spawn textures. In Niagara system, I spawned multiple texture with randomized rotation and added some details such as adding gravity and scales in particle update sections. I made a new Niagara system type variable in the header script of enemy character, subsequently integrating a spawn particle function within the same script. To enhance the particle replications, I'm considering to create a game instance script and storing the VFX reference within it to optimize the game. I'm also exploring the integration of attack animations, potentially blending static animation with procedural one for more natural transitions.
So here we see our multiplayer setup, and we've got a server window open as well as our client, and we can see that everything is replicated properly across both. This actually wasn't that difficult to achieve, as we saw in the code earlier, where we just had to work out exactly what to mark as replicated and then as net multi-class cast or as the server or client. It's very satisfying to see each of the health bars reflecting each of the players. So thank you very much, and I hope you enjoyed our demonstration video.